Welcome to the series of Study Smart. So, what is this series about? As the name says, it's about learning smartly, studying smartly. See, when we study, we definitely work hard. We put in a lot of study hours out there, and hard work is the key. There is no shortcut to the hard work. That is a fact. But there are certain tools and techniques that you can incorporate in your study plan. With those, you can reduce the number of study hours, but you can still study as much as you were studying earlier. So to put that in perspective, let's say you're studying 8 hours a day. Using a few techniques, you may reduce those 8 hours to 6 hours of study, but still learn as much. Rather, you can study more in depth, more clarity, more conceptual clarity out there. So I'm not talking about any shortcuts here. I'm not saying, okay, instead of deriving the formula, you start memorizing things so that you save your time. No, I'm not talking about any shortcuts. I am talking about learning via some study techniques where you really understand in depth conceptually and reduce the number of study hours. No, mind it that those 8 hours and 6 hours was just an example. So don't take those numbers literally. They're just an example. So put some numbers out there. So my point is, if you were studying X number of hours, you may study for less number than that X and still have the same kind of understanding of the topic. So we'll see one of those techniques today. But before that, let me introduce myself. My name is Bhavdeep Sethi. I've done masters from IIT Bombay, and with a passion of teaching and a passion of physics, I've been converting thousands of physics haters into physics lovers. I always say never memorize physics, learn with the nature around you. See, the nature is full of physics. Now, you don't just have to rely on your textbooks because textbooks are great. Textbooks are awesome, but not just the textbooks, but look around you in the nature, it's all physics. You learn from nature as well. So in today's session, we are going to talk about blank paper technique. See, this technique I have been using all my life. All my childhood, I used this when I was a student, and still a student. Obviously, every teacher is a student. But when I was in school and college, I used this technique for revision. So this technique works for revising things. And as a warning out there, this is very addictive. Once you learn this, you cannot get away from this. Because even today, when I learn something new, I always use this technique. And it doesn't just apply to learning physics, it's for any subject, and rather sports, cooking, whatever you learn, this technique is going to work. And it's really wonders. It works wonders. I can tell you, I have used it. Many of thousands of my students have used it, and they really thank me about teaching this technique. So this is really awesome technique. So what is this first of all? So this technique is a revision technique where you use a blank sheet of paper and a pen to revise, to recall the concepts that you have learned recently or maybe in the past. So you take a pen and a paper, a blank paper. When I say blank paper, I don't mean ruled or unruled. There may be lines here, that's okay. The whole point is there should not be anything written on the paper. It should be a blank paper. There's no notes, no formula, nothing. You should not have any books around you. You should not have any reference material. Ideally, this room has to be empty, and then it should be you, a paper, and a pen. Now, I'm not saying you ask your parents to remove all the furniture from the room. All I mean is, ideally, that is the thing that should be there, but other things will be there, but not any reference material. So that's the whole point. So how to use it? And then we'll also see the advantages, but how to use it. So what you do here is obviously you gather the material and you know I go for simplicity. Even when I'm teaching the derivations, I go for 4 or 5 lines of derivations. I never go for noodle methods. I go for chopstick method. So this is a very simple technique, nothing required here, just a pen and a paper. Now, maybe your digital age, you might have tablets out there. You might say, okay, why should I go for this pen and paper? See, the point is, if you have a tablet and you're using tablet to scribble, then you will be tempted to Google or go for Chat GPT and refer. That's the whole point. You should not have any reference material. Go old-fashioned way, paper and a pen. Maybe a slate will work, maybe a writing board. If you have a whiteboard in your house, you can use that, but no digital medium, I would rather say. Don't go for any tablets or phone or anything. So collect the material, then think about a topic. So now again, this technique doesn't work for learning a new topic. It is for something you already studied. Maybe some teacher taught you, or maybe you studied via book or YouTube somewhere, maybe awesome Vedantu classes, or maybe Bhavdeep sir classes. Somewhere you studied it in the past, maybe recent past or long back, doesn't matter, but you already studied and you want to revise it. So choose a topic, what you want to revise, and then start scribbling. Literally start scribbling. So taking an example, let's say you think, okay, Bhavdeep sir taught me the laws of motion and I want to revise it. Start talking about laws of motion here, right? What is the first law of motion? Then write some examples of body at rest. Okay, take an example of body at rest and draw pictures out there. When you study write about second law, start telling about what is momentum. Then you show a ball, it is colliding with a wall. I'm just giving examples. So draw a picture of a wall, ball goes in with MV, comes back with MV. Then you say, okay, delta T was the time of contact. So this is the change in momentum. This is rate of change of momentum. You write down all that. You just scribble, scribble, scribble. Whatever comes to your mind. It's as if you're teaching yourself. Think about your teaching yourself. Make diagrams, make bullet points, and then give examples. If required, make a numerical yourself. Make a numerical. A ball is coming to the player with so and so velocity, and the player stops it in so many milliseconds or whatever, and then how much is the force on the palms of the fielder. Make some kind of examples yourselves. Make numericals. Similarly, let's say you're trying to revise kinetic theory of gases. So make a cube here, maybe a molecule going there, rebounding back, and then say this is the size, and it goes back. So try to find like draw things, conceptualize things, and make up a new kind of derivation out there. Maybe you learned some derivations there. Now you're scribbling, you have no notes with you. Maybe you will come up with an idea. Okay, teacher taught me to derive this in this way method. Maybe there are alternate methods out there. So you do whatever, but related to the topic, just scribble, scribble, scribble. And why are we doing all this? Why are we doing all this? Because once we do this, it improves our understanding to the level that you will not imagine. Because what happens is when you have a blank paper and you're writing on it, you might come up with new thoughts. You might also come up with things that you were not even taught. And then you will identify your knowledge gaps. Because let's say you opened the book and you studied the three laws of motion in the book, and you're reading and you're saying, okay, I do understand it, but maybe you understand 80% of it, you don't understand 20% of it. So reading that book, you're not able to identify that 20% part, because everything is right in front of you. 100% is in front of you. You're reading and you're saying, oh, I understand all this 100%, but you don't know. But when you have a blank sheet of paper and you literally have to write from scratch, you will get stuck up somewhere. You will get stuck up. And then you will say, okay, the what happened here, the pressure is this, maybe the velocity the teacher told me is V, so momentum is changing so much. But then you forget the part that you have to take the component of the actual velocity, and you get stuck up there. And this is where you identify the knowledge gaps. And when you find that blocker, you do not go to the book still. You just make a margin here. You write down the points where you're getting stuck up. Because what will now happen is after you have worked a little on this, maybe you will identify where you were getting stuck up, and you will come to know what the solution is yourself. And that is the best way to learn. And let's say you're not able to identify, then that list is the list that you have to go back and reread from the book. So you are able to identify the knowledge gaps. In absence of this technique, you will not be able to identify, because in the book, 100% of the material is right there. You do not know where you will get stuck up. You're reading the steps, ha, samajh aa gaya, but you don't know where you actually are not understanding. Now, this is about being creative and out of the box thinking. As I already said, your teacher taught you something, But then when you come back to the blank paper, you're trying to derive the same thing out there. You will come up with new kind of techniques out there. You might say, okay, these are the steps I was told. So these steps are like 7 steps. Maybe this was redundant out there. We don't need this. Or maybe you will say, yeah, this looks good. Teacher taught me awesome. But then there is an alternate way. So that is all physics is all about, because there are multiple ways to come up to the same solution. And finding that out of the box or creative thinking is what makes you learn more. I mean, in absence of this technique, you were not thinking creatively, you were not thinking out of the box. You had your notes in front of you or the book in front of you. You're just reading what you were taught or whatever is printed in the book. So that is not promoting the out of the box thinking. So this technique is going to make you think more, think something new out there. Then it basically boosts your confidence. Now you're fully confident that I don't have any study material and I was able to write everything here. I am master of this topic. This confidence is going to help you in the exam, because think about in examination hall, you don't have any reference material. So let's say you're given a homework from the school, you come home and then you do that homework, but you have all the study material around you. But when you have to solve a question in the exam center, you don't have any reference material. So now when you're using this technique, you know, wow, I don't have any material with me and I was able to understand this so clearly. I can go to the exam. Tomorrow I can give the board exam. Tomorrow I can give the JEE exam. That is the kind of confidence we are talking about. And obviously, as I already said, this simulates the exam center conditions. Because in examination hall, what you have is these two things. Examination center, you won't have anything more than this. So you're simulating the exam center conditions, and that is boosting your confidence. Now, this improves your memory retention, because now you really have to think back. Okay, now this, now that. Okay, I'm not getting it. I'm not getting it. Let me try to recall. So this is really giving your brain a good exercise. And then obviously it's about active learning, because there are two ways to learn, passive learning and active learning. When you're reading a book, it's actually a passive learning. When you're doing this technique, I will keep showing this to you. This is what we're talking about, the active learning. You're actively involved in it, because with passive learning, it is given to you and you're consuming that. This is active learning where you don't have anything and you are the one creating the content, and that reduces the boredom also. And that keeps you alert all the time, because with passive learning, okay, aata aata samajh aa gaya, but this is all about the active learning part. So now let's use it. I mean, instead of speaking so much, let me show that in action. So how do you use this technique? First of all, you grab a paper and a pen. Now, see, honestly, if I use the technique here, you will not be able to see that because it's going to be very small. So what I'll do is I will say, okay, what about where's my pen? First of all, I'll grab a pen here. So I'll grab this pen and this writing pen, and maybe this is my paper for now. So okay, done. Check. Choose a topic. So today I'll choose a topic, let's say relationship between pressure, temperature, and molecular velocity. So basically, if I know the pressure of a gas and the temperature of the gas, I want to relate that with the molecule's velocity. And this is something I learned in Vedantu classes, let's say recently, and I want to revise it. And I'll show you how to revise it. Maybe I'll not completely do that. I'll just show you in action how to do that. Now, the next part was after you decide the topic, you scribble, scribble, scribble. So let's start scribbling. Okay, I have a blank sheet of paper. Let's say even this is not there. So blank sheet of paper, and I'm thinking, okay, so pressure, temperature, and then velocity. So let's say pressure of a gas, obviously. So let's first create a container out there. So maybe I can draw. No, no, no. See, that's another thing I'll talk about. You really have to make sure that you're not a perfectionist here. You just scribble. You don't worry about your handwriting, your ugly diagrams here. You don't do all that, because as soon as you start doing it, it defeats the purpose of it. So I have drawn a cube here. Then I'm thinking, okay, gas molecule. Let me take a gas molecule here. So there's a gas molecule. Maybe I'll paint it yellow. and let's say it has a mass of m, and then it has some velocity. Now, it may not be going in this direction, it may be going in 3 dimensions. So let me talk about its component along the x-axis as v of x. So this has a momentum of mvx. Now it goes, collides, and comes back. So momentum being a vector quantity, there is a change of momentum. So there's a change of momentum. So then there has to be force involved, and the force is the rate of change of momentum. So first, let's see how much is change of momentum. mvx, mvx, so change of momentum, delta p in the direction of x. Or maybe we don't have to write in the direction of x. We know that's x. So to save space here, so delta p here is 2m v of x. So I know, okay, that's the change of momentum. Now this molecule goes there, collides, comes back, travels all the way, goes back again, again collides. So it hits every some seconds or milliseconds. And what is the duration of time? Speed is equal to distance over time. So distance over speed is time. So distance is, if this were L, so let's say this side is L, this is L, this is L. So L and L, 2L, distance is 2L divided by speed is the time duration. Again, it will collide. So we can say, oh, what's the rate of change of momentum? It collides every 2L over V of x. Okay, that seems to be the force. But that force is from one molecule. Then I'm just saying, you just keep thinking, okay, that's one molecule. But then there are so many molecules, all of them colliding, colliding, colliding. Okay, maybe let's say there are n molecules. So if this is the force from one molecule, then you can say, oh, the total force is multiply this with n, whereas n is the number of molecules. Oh, wow, it's working. So then you can cross out this and this. So that's the force. And how much is the force? We are saying force is equal to this Vx goes up. So n times the mass of each molecule times velocity x square over L. Okay, perfect. Perfect, perfect. Then I say, okay, no, I needed pressure. Pressure is force by area. So what is the area? L over L. So then I'll write over here divided by A. So that's L square. So then I'm thinking, I'm just telling you how you would do this. Then maybe you get stuck up here, not knowing what to do. Then you say, okay, this is the pressure. How do I relate with, okay, this mass of one molecule times the number of molecules, that's the mass of the gas in this container. So that's the mass in this container, and this L times L square is L cube. That is the volume of this container. Wow. This is the mass of the gas here divided by this volume. So that's the density. That is the density of the gas. So you can say, oh, the pressure is equal to density times Vx square. Then you're thinking, okay, in the classroom, and you think, okay, you're done. And this is how you're doing this blank paper technique. You're thinking, okay, I'm done. But then you recall, like remember that memory retention kind of thing. So when the teacher was teaching, when Bhavdeep sir was teaching, there was one by something over here. There was a fraction here. It was not such beautiful thing. Then you're thinking what went wrong here. Then you say, oh, actually the velocity is in 3 dimensions. And I'm just taking Vx component of it. So you know, if the velocity were V, so using Pythagoras theorem, you will say that is equal to Vx square plus Vy square plus Vz square, because that's the way the Pythagoras theorem works. Now I want to find Vx, but it is so random here. There is no preferred direction of motion. So Vx, Vy, Vz, they're all same. So I can rather write this as 3 times Vx square. So Vx square is 1/3 velocity square, where V is the velocity. Then you will say, okay, I can say this is 1 by 3 of the velocity. And this is the formula. You will say, okay, wow, this is the formula for the pressure of the gas. And this is how you learn. This is how you learn. This is the way to learn, brother. And then you say, okay, see how I'm able to relate the pressure with velocity. If I know the pressure of gas here, First of all, isn't this so amazing? I mean, let me put down this pen, and sometimes I'm really amazed by these things. Pressure is something that you can measure. And you have so many meters out there, you can measure the pressure of gas in this room, pressure of gas in a container, yeah. And molecule you can't even see. But look at this expression here. You can calculate the pressure using a meter. You know the density of the gas. You can measure that mass over volume. And using those measurements, you're able to find the velocity of molecules. The molecule that you cannot see, you're able to find the velocity of that. This is amazing, I would say. If you aren't amazed, you should be amazed. So what we are getting here is this, and this is how you use this technique. And you can use this technique for anything you want. So something you learn new. Let's say you learn simple harmonic motions. And then you're saying, okay, let me try to derive the work done when you stretch a spring. And you're saying, okay, let's say there is a spring with a spring constant of K. And what would now happen is if I pull it, I know the force is K times of X. But that X is the extension. But there is no extension, so there's no force. And then you say, okay, if I apply a force, it is extends, but then as it extends, the force is more. And I would like to know up to this point, if I'm stretching that spring, how much is the force? And this is how you start going into the calculus part of it. Now, the whole point is when you're doing all this, you will be getting stuck up. And once you get stuck up, you never refer to the material because that beats the purpose of it. You just depend on yourself. And then if you're not able to do it, in the worst case, you will go back, but that goes down to finding the knowledge gaps. And you put an extra effort to learn that. Now, few tips and tricks here. You will definitely improve with consistent practice because initially when you try to follow this technique, you're going to basically refer to the material. You will give up. You might think, okay, nahi aa raha yaar. But going to get better and better. So don't give up. Try it for 1 week at least before you give up. You will not give up. I know that. Now, mix topics and subjects. So this is not just for learning physics. This equally works for, let's say, social science. So let's say you have studied French Revolution. Now, when you're studying French Revolution, you basically know, okay, this, you're reading, aa gaya, samajh mein aa gaya. But then when you have this paper, you start writing. This happened and this happened in this year, this happened. And then you say, okay, I read the next chapter. Then you go to the Russian Revolution. And then you say, okay, Russian Revolution is completely coming from French Revolution. So those two chapters are not independent. And then you start take, okay, this happened in France and the news spread out through the Europe and the people are following the same things. And then you see, okay, all the democracy out there in the world today, it's coming from that French Revolution. You scribble all that. You start writing history. And that is how you learn. You do it for different subjects as well. Now, this technique gets better if you can incorporate the peer review. So maybe once in a while, you sit down with group. So you are writing and explaining your friend and your friend gives you out inputs on that. So यार तूने ऐसा किया, you could have done better by maybe organizing your thoughts this way. And don't let that influence your thoughts, but there is something good that will definitely come out from there. So if possible, have peer review, your friend reviewing you and you reviewing your friend. And this will work good when you're doing a group study as well. Right. Now, any pitfalls to avoid? Definitely there are. So do not cheat. This is the first advice I will give. If you are getting stuck up, don't give up. Do not refer to the notes. Do not refer to the books. Try to come up with yours, especially with physics. Now, see, let's say you get stuck up with history. Now, if you don't know a certain year, a certain event happened, now there's nothing much you can do. I mean, if you haven't read that year, that you have not read that piece of information. So, right. So there are certain things, if you have not studied, you can't do anything about. But things like physics and maths, even if you have not studied, you can come up with your own kind of and solutions to those. So don't refer, don't give up too soon. Avoid perfectionism. See, that's the whole point here. If you're trying to make it okay, it has to be very beautiful kind of thing. I should not be missing anything out here. It has to be perfectly oriented and it has to have everything in place. No, that doesn't work. It's about scribbling. That's why I use the word scribble. You just write in your ugly handwriting, ugly. I'm not saying make your handwriting poor. I'm not saying that. All I'm saying is, see, when you're thinking fast and you're writing slow. You should know that your writing speed is always less than your thinking speed. And if you're trying to write in a perfect handwriting, then your thoughts are slowed down. But that should not make your handwriting poor. I'm not saying you keep your handwriting, but all I'm saying is just try to write a little faster there so that your thoughts are not stopped. They should not be pausing over there. Now the next one again is do not skip steps, obviously. So if you're doing a derivation, do all the steps, write all the steps. Writing is the part here. And this one I'm going to speak a lot about. Do not save these as notes. So there is a big temptation out there. यार इतनी मेहनत कर ली रख लेता हूँ notes बन गए मेरे तो नहीं. That thought itself will make you go perfectionist. Because as soon as you think इसको notes की तरह रख लेता हूँ, you're trying to write it as a perfect note. No, that is not the point here. The point here is to make you learn here. So there are two different things, notes and this technique. They are completely opposite of each other. Notes are something you're making so that you can refer to that at later point of time to have a understanding of the topic. So notes is something you have read and you're putting it in your own words, and the purpose of that is बाद में इसको पढ़ के अच्छी तरह समझ लूंगा. The purpose of this technique is बाद में नहीं, अभी अच्छी तरह समझ लूंगा. You have to understand it right now, right here. Those things are going into your brain, not on this paper. This paper is a tool to make it go into your brain. Do not ever be tempted to keep them as notes. I am telling you, many students have done that and they come back to me and say, sir, अब ये हो रहा है, ये हो रहा है. Then I try to analyze. अरे बेटा यही तो गड़बड़ कर गए यार. Never mix these two things. Notes are something different than these techniques. Notes are, again, I will repeat, notes are something you're making. Next month एग्जाम है उससे पहले एक अच्छे से अंडरस्टैंडिंग हो जाएगी. दिस टेक्निक इज अगले महीने नहीं, अभी अच्छे से अंडरस्टैंडिंग करनी है, इसको स्क्रिबल करना है, नोट्स नहीं बनाना. एज सुन एज दिस पेपर इज फुल जस्ट थ्रो इट अवे. एंड आई बीइंग अ ग्रीन काइंड ऑफ पर्सन, आई नेवर थ्रो अवे द पेपर. आई पुट इट इन अ कंपोज्ड बिन. है ना, हमारे कंपोस्ट को कार्बन मिल जाता है भाई. सो डोंट थ्रो पेपर. पेपर इज प्रेशियस. इट इज कमिंग फ्रॉम ट्रीज. डू नॉट वेस्ट इट एवर. Once this is full, put it in a compost bin maybe, or your neighbors might have it. So this is a thing you have to avoid. Does it really work? Yes, it worked for me. It has worked for hundreds of my students. I have recommended this to thousands of students, and not everybody follows. Obviously, everybody has a different style of studying, but hundreds of my students have used this technique and they have thanked me. Sir, ये तो मस्त है यार. So it works basically. Try it out, you will fall in love. I can guarantee. This is my guarantee. एक week try करो, you will fall in love with it. So is there any better technique? Yes, there is. And that is teaching to somebody or yourself. So this was the first step. Before the second stage, you have to learn this. Once you master this, you can always go for my next technique that I'll bring soon, that is to teach. Teaching is the best way to learn. And I'll come back with that video later on, but until then, you have to master this technique. And I'll definitely talk about it very, very soon. So was it helpful? Please give me a yes or a no in the chat box and the comment box. And students, I read all the comments that I get on the YouTube and I try to reply to everybody individually. Personally, I reply to everybody. And then I'll see you soon. And by the way, if you noticed, I might have given I'll give my Telegram ID also. In case you want to contact me, you can definitely contact me at Bhavdeep 680. That's one word. So if you have any questions or if you have any suggestions about making topics or videos, you can contact me, Bhavdeep Singh Sethi. That's my Telegram ID. Okay. So I'll see you very, very soon. And by the way, we have launched a new course on Full Physics Mastery 2025. I'll briefly tell about it. So this course is from July 2024 to November 2025. It's a long-term course. And as the name says, this is mastering the physics, the whole of the physics. So we are talking about 11 and 12 syllabus for NSEP, JEE, NEET, full syllabus, full syllabus. Even the deleted portions that CBSE has deleted and some of the JEE topics that have been deleted, we'll cover those also. There will be 120 plus of live classes. Every alternate Sunday is a test, and after every class, you get a Telegram mail and a PDF of assignment and their solutions also. Doubt clearing happens on Telegram. There's a group that you'll be part of. You'll be clearing all your doubts, and the fee is only 12,500, and there's a 12% discount via the coupon PHY20. So PHY as in physics. So the fees of the whole course is 12,500, 20% off is only 10,000 rupees, and that covers the whole physics, 11th and 12th. But if you want, you can go for the module wise. So this course is divided into 5 modules. You can buy different modules. You can buy the first module, then the second one. So each module is 2,500. So 2,500 times 5 was 12,500. But if you buy module wise, you get 10% discount, not 20%. So that is with BS Pro 1. So BS PRO 1 1 and a PRO 1. And the links are in the description here. You can click on those. I would say go for the full course and save that discount, with the money of them. So I'll see you soon. And this is the 5 modules. These are the 5 modules I was talking about. This is all 11th ka syllabus. This is all 12th ka syllabus. And you can see July to September, the syllabus will be over. And then in October, November, we are going to do revision and PYQs of NSCP. So these classes will start on 1st of July and they will go on till November, mid or maybe end of November, depending on when is the NSEP exam next year. We don't know yet. It happens in November, but the dates we don't know yet. Nobody knows. So Dhruv is one of the students who started the journey at Vedantu Olympiad School. He got gold medal at International Physics Olympiad. Similarly, Aditi and Avnish got silver medal in International Chemistry Olympiad. And as we talk, there are 4 students competing on the international stage, and these are from Vedantu. So I will see you soon, my dear students. Whether or not you're coming to those classes, always keep up the high Josh and always stay connected on YouTube with me. Forward this video to your friends as well. So see you soon. Keep up the high Josh. See you.